Let's try to solve absolute equations. Now here we have two absolute functions and we should be in a position to write them as piecewise function and then solve the equation. 2x plus 1. So let's see what 2x plus 1 absolute value should be. 2x plus 1 absolute is actually defined as plus of this value, the same as 2x plus 1, if x is greater than or equal to, what will make this 0? Minus 1 over 2. So if it is on the right side of 0, it is always positive, right? So when x is greater than or equal to minus half, is it okay? But what will make this negative? If it is on the left side of 0, and the 0 value is minus half, right? So it will be negative of 2x plus 1 if x is less than negative half, right? Similarly, let's see what absolute function 3 minus 5x should be defined as. So this should be defined as 3 minus 5x if 3 minus 5x is greater than or equal to 0, correct? Now let's solve this. 3 minus 5x greater than or equal to 0. So let me write it here. So we say 3 minus 5x is greater than or equal to 0. That means minus of 5x is greater than or equals to minus 3. Now we can divide by minus 5. When we do so, we have to change this inequality also. So if x is less than or equal to minus 3 divided by minus 5, which gives me 3 over 5. Do you see that? So this actually means when x is less than or equal to 3 over 5, then it is positive, right? So if it is positive, it should be taken as positive only. But if it is less than 0, then it should be made negative. So for the time being, I'll write this as minus of 3 minus 5x if 3 minus 5x is less than 0, correct? That's understandable. Now, what does this mean? This really means that here, that means x is less than or equal to 3 over 5. And here it means x should be greater than 3 over 5. Do you see that? It's very important to understand. That's a very, very tricky question, right? So you have to actually see when is this thing positive and when is this thing negative. Correct? Now, if you see a number line, then on a number line, we can check where these points are. Let's say this is minus half, and let's say this is our minus half, which will have, like, if we are on this side, then this function 2x plus 1 will be positive, but on this side 2x plus 1 will be this negative value, correct? Now let's look into this function. Now this function is defined positive if x is less than or equal to 3 by 5, okay? So let's say 3 by 5 is kind of here. Correct? So if we are on left side of 3 by 5, then this function is positive. Do you see that? That's kind of tricky, right? That's what you have to understand. Well, these 2 points actually divide our line into 3 portions, right? And therefore, this equation has to be solved in 3 different parts. Okay. Now, on this side, let's say from the left side of the line, if we consider the left side of the line, that means we are less than minus half. In that case, absolute value of 2x plus 1 is negative of this, right? Is negative of 2x plus 1, right? We'll write plus 3 here, equals to, and if we are less than 3 over 5 on this side, then it is positive this value. Do you see that? Then it is 3 minus 5x. Do you understand that part? So this case, let's say this is our case 1, right? In this case, let's write this as a case 1. Right? We have this as a positive value, but that one as a negative value. We have to solve this equation. Case 2 will be when we are on the right of minus half. So when we are on the right side of half, that means x is greater than equal to minus half. Then this value will be positive, right? So here it will be 2x plus 1 positive, right? Plus 3 is equal to. Now, what about this? We are on the right side of this, but on left side of 3 by 5. So 3 by 5 less than 3 by 5. So when we are less than 3 by 5, at that case we are taking this as positive, okay? So this is equal to 3 minus 5x. Let me write it here, equals to 3 minus 5. So this is the equation we have to solve in case 2, right? And how about case 3? Case 3 is that we are on the right side of minus half on a number line. That means x is greater than equal to minus half. So this is positive. So we have here 2x plus 1 plus 3. So the absolute value of 2x plus 1 will be written as 2x plus 1, right? And when we are greater than 3 over 5, then we have to consider negative value of this, correct? So it is minus 3 minus 5x. You know why this is kind of reverse? Because in the absolute function, we have minus here, minus 5x. That makes all the difference. If you see that kind of a thing, then remember to consider your equation like this, okay? Now we can open these brackets and solve for all the three cases, and let's start doing. So here we have minus 2x minus 1 plus 3 equals to 3 minus 5x, correct? We can bring x's together. So when we bring 5x here, we get 5x minus 2x, right? And we have 3 here, and we can take these things there, right? Let me just write plus 1 minus 3. Okay, 5x minus 2x is 3x, and this is 1 for us, and therefore x is equals to 1 over 3. This is one of the solutions, right? Once we get our solution, then we have to check whether this solution x equals to 1 over 3 is within the domain we are working. Do you see that? Now, what is our domain? Our domain is that x should have been less than minus half, but 1 over 3 is not less than minus half. Therefore, we say that this is not a valid solution, right? Not valid. So we'll not consider this one, okay? Let's check the other one. The other one is, let's solve it. 2x plus 1 plus 3 is 2x plus 4, right? Equals to 3 minus 5x. And when we bring 5x here, it becomes 5 plus 2, 7x. And 3 and 4, so 3 minus 4 is, let's write 3 minus 4 now. So x is equals to minus 1 over 7. Now, does minus 1 over 7 lie between minus half and 3 by 5? Yes, it does, right? Minus 1 over 7. Does it lie here or no? This is what we have to see. If it lies, then it is a part of solution. If it does not, then it is not a part of solution, right? So, minus half is like 0.5. You can convert to decimal numbers, right? And minus 1 over 7 is 0.1 something something, right? So, which will be kind of closer to 0, right? On this side. Therefore, this is valid solution, right? So we say, okay, that is fine because it lies here. Let's check another value. Case 3. Case 3 gives us a solution like 2x, 1 plus 3 is 4, right? equals to minus 3 plus 5x. Now, when I bring this 5x here, then it becomes minus 3x equals to minus 3 minus 4 is minus 7, and when we divide by minus 3, we get 7 over 3. Now, is 7 over 3 on the right side of 3 over 5? Well, we can make them common denominators and then check. So if I multiply this by 3, we get 9 over 15. And if I multiply this by 5, we get 35 over 15. So this is very much on the right hand side. So this is also a valid solution. Okay. So we get two valid solutions. And so we can write down our solutions here. This is the answer to our problem is that x is equals to minus 1 over 7 and 7 over 3. So these are our two solutions, two valid solutions for the given equation. Okay, I hope you understand here that when we have this kind of situation, we could have number of cases to solve because the piecewise function is defined as a combination of two. So wherever it is 0, on the left and right side, on the right side it is taken positive value, and on the left side we have to take its negative value. Similar is the case for the other one, and that leads to 3 cases. Then when you get a solution for each case, you have to check whether you are in the domain or not. If not, then the solution is not valid. If you are, then the solution is valid. Therefore, here we get two valid solutions, and our solutions are minus 1 over 7 and 7 over 3. Perfect? Thank you.